Well, if you type ./a out, copy in reverse. So,
all right.
as far as you know.
as far as you know. It's actually kind of funny. Is there actually a reverse system call?
That was the first thing I thought about. It's just a reverse.
He just goes in and edits.
Edits eight. TAC is supposed to reverse it.
He goes in and just edits A dot out. No longer a binary. Now it's just a file that calls reverse. All right. So the way we're going to solve it here is in terms of the universal I/O. So the fseek thing we were talking about last time deals with specifically with file streams. All right. So file streams is kind of a newer, still POSIX standard thing, but it's a newer thing that lives on top of universal I/O. So because of where we're going with this, I want to solve this problem entirely using universal I/O, which means using nothing that isn't in this version of copy. All right. So
You didn't have to do that, though, right?
no, you could have. Well, I mean, I'm not sure exactly what you did. You could have solved it however you wanted to solve it, I would suppose, within reason. If it was just like a call to a reverse thing that already exists, that might not be legit. But
He just wrote his own Java program that does it.
they called your Java program.
No, I just didn't use I could not have it not throw errors with trying to use write and open and stuff like that. You know what I mean?
Okay. And
So
did
then I
you?
was so then I just started to use the fopen and
Okay, so you use the file stuff.
Yeah.
Yeah, and that's fine. That's fine. I'm gonna solve it just with generic I/O. Just cuts. So what I'm gonna do is I'm gonna start off with this, and this is some of the things we've already had to grapple with when we were learning about that second parameter. Well, the two parameters that come into main. First one being the argument count. The second one being the actual list of arguments, array of arguments. So in this case, we don't know how long a file is. So we want to kind of change our mindset into thinking about a file in terms of how many bytes are in it. And I gave you a hint on Slack that you are allowed to read a single byte. And you are allowed to write a single byte. So we're going to make a little modification here. So instead of, actually let's, just for the sake of, I'm going to duplicate. Can I duplicate this? Yeah, duplicate.
And call it copy reverse.
And rename. We're going to call this copy reverse.
Yep.
Boom. Nailed it. Okay. So I'm going to start off by changing the size of my buffer to just 1. We're going to literally read in 1 byte at a time. Now, what we're going to start off with here is we need to figure out how many bytes are in the file using only the tools that we have sitting in front of us. Now, we could probably assume there are some built-in libraries, specifically file I/O libraries, that allow us to ask the size of a file, right? Seems like something that probably exists, all right? But we're going to do this completely with universal I/O. Chances are they wrote these the same way we're about to write this. So I'm going to create a function that's going to open up our file name, our input file, and go through and spit out how many bytes are in it. That's it. Now, if we were to write, how would you write that in terms of what we have right here? Based on the things we've looked at so far with this copy.c, how would you write a function that goes through, or we can forget about a function, we're just going to write it right here in main for right now, then we'll move it into a function. How would you write the code necessary to determine how many total bytes are in our input file? Good.
I guess my initial reaction would be to just do a for loop and have it go through and just go next byte, next byte, next byte, next byte, and just have a count variable.
And we also already have the while loop, right?
Just have it
So doesn't this guy read from our input into our buffer? How big is our buffer? Well, it happens to be buff size, which is 1. So our buffer can hold 1 byte. The most we'll read is 1 byte. And we're going to keep reading as long as numRed is greater than 0. So in this case, numRed will always either be 0 or 1. because we're only going to try to read 1 byte. So inside here, we're going to go ahead, we're going to say int numbytes start off at 0. And I'm going to take out, I'm going to gut a lot of this right now. Okay. In fact, here I'm gonna delete a lot of this right now just to keep it, to slim it up. We'll bring it back in from copy here in a little bit, because we're not even dealing with an output file right now. All right. So we'll come in here. We have a whole bunch of variables that we're not using right now. We will have them, so forget about, we'll just leave those in for right now. So we'll go ahead and create our buffer that's going to be of size 1, open up our input file, and then count how many bytes we have. So we'll start a counter off at 0. We'll go through them each time through, we'll try to read 1 byte. And as long as we read something, we'll increment the number of bytes that we read. Make sense? All right, and then in the end, we want to go ahead and print out numbytes. So print
What
number.
happens when you hit the end of the file?
Nothing. This while loop will end because you read in 0.
Oh, right.
We won't count it. So we're counting the actual bytes that are found, as in the number of 1 byte bytes, pun intended, 1 byte bytes that we can take out of the file. All right. So number of bytes. This is going to be %d, comma numbytes.
So refresh me, what's %d?
Decimal. Placeholder for a decimal. All right. And let's see, what files do I have here? Here, we'll do copy. We'll do copy.c. So I'm going to do gcc copy reverse. Oh, print f. Okay. An interesting thing that you could do, and this was something that Haxton had pasted in there when he showed the big, long, crazy flags you can give this to make it actually compile the code from the book. Instead of using GCC, you can do C99. And what that is doing is it's using the most up-to-date C compiler, C flags. So this allows things, so for example, if you don't use C99, you can't do like for int I equals 0, blah, blah, blah. You have to define I before the loop, and it'll give you a warning. All right, so you could just choose to use C99. I think C99 is actually just an alias for GCC. Yep. So I think it actually is an alias for that. Okay, but in any case, for this code, it wouldn't make a difference. So we'll do a dot out, and we're going to do copy.c. We don't have to give it a second file since we're only reading in the file, and this should spit out the number of bytes that are in there. 815 bytes. So that's right here. 815 is the, if you want it to look a little nicer, there's our \n. There's our 815. All right, that's the number of bytes that are in that file. Now, what we want to do is we want to go ahead and take this logic and move it into a function that we can call from main. All right, that way we can just pass it the name of the file and have it return for us the number of bytes that are in that file. Make sense? All right, so we already have a model for defining a function right here. So we'll go ahead and do this again. So we're going to have a function returns an int called get num bytes. And this guy is going to take in a char pointer file name as a parameter. All right, and we're going to go ahead and steal some of this stuff. So we'll grab our input file. And this guy is going to open this, whatever file name we pass in there. And then we're going to go ahead and have a num bytes starting off at 0. And we have to have a num red that's of type size. Then we can have our loop here. And ultimately we can return num bytes. All right, so that is get num bytes. To give it the buffer as well in there. Go ahead and close our file when we're done. Not necessary, but it's a good idea to do it. And then exit. All right, so now whatever we pass in, it'll go ahead and pass it to get num bytes right here. And we'll print out the decimal that's returned from that. Didn't I use C99?
Oh, you have to do the
Prototype.
Okay.
But I used C99. I didn't think that should. Here, let me try something here. I'm gonna do GCC. Ah, that's funny. That's weird.
That doesn't make any sense. to
Wait,
me.
GCC works with
Yeah.
what? That's backwards.
So C99 follows the newest standard, but is a 1-pass. GCC is a 2-pass, but doesn't natively follow the newest standard. Yeah, whatever. So there's our 815, same output. If I want to give it a different, don't I have a something? Oh, that also is the that's the copy, right? So let's
How do you get the file name like that? Is it a key that you're clicking or something?
what do you mean?
Shortcut?
Autocomplete the name of the file.
You're just hitting
Everybody's-
and it goes.
Are you talking about that?
No.
No.
You start typing out a file name. TL.
Dot slash that?
Yeah, that. How'd you do that?
I used the force. Didn't you see Yoda pull the lightsaber out when he was fighting Dooku?
What is called tab?
Yeah, you just hit tab.
Just now.
It's not how the force works.
It's not how the force works. What was that from? Oh, that's right. That's right. It was a new one. Did you see that one? Spoilers.
Now it's ruined. Spoilers, Vader's Luke's father.
Who?
Vader's
What?
Luke's father.
Somebody found like an article from like the 80s before that actually came out where it just spoiled the
Oh.
whole like plot twist in the paper before the movie even came out.
I assume everybody in here has seen the new Star Wars movie, haven't they?
And if you haven't, you really don't care.
Yeah, at this
They
point
haven't,
you
they
should have, or
really
you don't
should
get to
be.
care
Who,
about.
has anybody not seen it? Isn't that kind of an interesting?
I think the real
If
question
Pebbles
is
were
how
here,
many
he probably
times
wouldn't.
have you seen it?
Well, no, but isn't it actually kind of an interesting,
Three. Each.
an interesting thing? I mean, it's probably fairly rare for you to ask about any movie, regardless of how popular it is, and literally have 100% of a class say they've seen it.
I would say not with. You haven't seen it?
I just asked the question, and literally,
He raised his hand.
I asked it twice.
He raised his
He's
hand.
Amish though. He doesn't.
Show me how you raised your hand.
He shouldn't be included in.
You did not raise that hand because I would have seen it.
blocked you because of Austin. How Randy always raises his hand.
You gotta
My
remember,
hand's shaking.
he's the doctor. He really only shows up in like photographs in the background.
And why didn't you see it?
Make sure you would see his hand.
Because like I haven't seen it.
Have you seen the old Star Wars movies?
Yeah.
So you've seen like all the Star Wars movies except that one.
I haven't seen prequels.
So you haven't seen the whole stuff.
He's an original.
You've seen the old Star Wars movies. So you've seen the bad Star Wars movies.
Oh.
If you want to classify it as that.
Do you ever want your driveway snowboard?
Hey, the old ones are great if you had the newer style lightsaber fighting. I think they should go back and remake the old ones with like not Mark Hamill. All right. So now we have a function that we can just call whenever we need to that tells us how many bytes are in a this file. All right. So now what we want to do is we want to write another function that gets us a certain byte. So think of this kind of like the char at method for strings. And so we're writing modular code. Now understand that this is going to be inefficient from an I/O perspective. But from our perspective, it's going to do the heavy lifting for us, right? So we're going to write something that literally gets exactly 1 byte, byte number 7, okay, from the file. So we're going to have, and this guy's going to actually return an int, not a char. Chars, when we return it, it's going to return as a byte, which is an int. And then when we print it, we can print out the char version of it, okay? Kind of an interesting thing. In fact, here I'll show you the error you get. I'm going to do a char get char at index. And let's have this guy take in an index. And really what we're saying there, and I need to give it a file name as well, char pointer fn. I'm going to steal pretty much all this stuff. Okay, so we'll go ahead and open our file, be able to start reading stuff. Yeah, here, this is where we will do we don't need a num bytes. We're going to assume, since we're not error checking any of this stuff, we'll assume they're going to pass us an index that exists. So now we want to burn through some number of times and ultimately read that last thing. So we're going to say for int I is equal to 0, I is less, and this will let us see the error message for the for loop. I is less than index, I plus plus, and then we're going to say that. We'll go ahead and read into our buff size. And then finally, we can close this guy. And we're going to return buff at bucket 0. Buff at bucket 0. All right. And so I'll just do a second print statement here. Printf the byte. Here, we'll just call it a byte. Is %c, and this guy is going to be get char at index, and we're going to pass it argv at bucket 0, and we'll pass it 3. So get me byte number 3. So if I pass it this file, well, I'll pass it copy. So this is 1, 2, 3. It should give me the n right here. This guy right there. That n. Okay. So let's go ahead and save this. We'll recompile it with GCC. It should yell at us about for loop. This only is allowed in C99 mode. But now if I do C99, it's going to yell about the other thing, right? It's very interesting. Well, here. Everybody's happy again. I should be able to use GCC. Oh, I actually have to give it an initial value. Okay, yeah, so this is the other error. So it does not like me returning a char here because I'm actually returning a byte. Now, I could probably cast this to a char, would be my guess. No. What's this? Yeah, it treats bytes as integer types. So, and I guess you can't directly cast it. I'd have to do what, I to C, or is it B to C? Byte to int. I think it's B to C.
Something that you can just do ampersand, then in parentheses, and then the thing, and it does it. But it didn't work for me.
Say this again.
It's just ampersand, and then in parentheses, buff 0. And that works.
Oh, if you did that, then you'd be returning the address.
Oh, okay.
Yeah, so yeah, you could do that. You could say I want to return a char pointer, and then this guy would then become a C, and we'd say star that, give me the address of that guy. So give me the address of this, which should be a char pointer, which will come out in here, and this says give me the value of that address as a C. Let's see. Oh, but this breaks as well. Well, no, it shouldn't, because this does not have automatic garbage collection, so this should actually be okay. It's saying if you don't want to see this, just the dash W, that is for what warnings you want to see. So you can turn off if you wanted to stop yelling about stuff. When you see something that has a whole bunch of dash W's on it, it's suppressing warnings. Yeah, so let's see, because there's no automatic garbage collection, so technically that memory address should still be available. So let's run this. Give me an L at bucket 3. Wonder why it gave me a big L. I think it's giving me something else. Let's get the memory address it just returned. Yeah.
Are you sure it's compiling?
I don't think so.
No, you got error. There's no way it's compiling with error.
Oh, conflicting types get chart index. So it's saying that this guy is conflicting with this guy?
You just need a header.
I saw if you
thing,
put that in
whatever you
parentheses,
call it.
we have it right now. That was the syntax that I saw online.
Well, I mean, it should do the exact same thing, because this is ultimately going to give you, actually, no, it won't do the same thing. You're right, because this is going to boil down to the value at that, and then you're asking for the address of that, where we really want the address of bucket 0, which actually is the same thing as just saying buff. So this guy right here is synonymous with just that. Because buff is a char pointer. Okay, so that one's a warning.
To have that declaration line, essentially, which you would put in the header.
Well, yeah. Well, no, you're saying prototype.
Yeah.
You want me to prototype this guy up here?
I'm like 99%.
Well, but I shouldn't have to do that with GCC. Yeah, but GCC should not make me do that. All right, there's the memory address. Then here's the where's the L? Where's that L coming from? I still don't think this is right. Get rid of this. Change this back to this, and I'll just actually return the byte. Get rid of that. We're saying give me byte 3. One, two.
Print it as a number. Print it as a character.
Well, no, I want it as a character.
You're gonna print the byte number as a character, or
If it's going to come out as a byte, if it's going to come out as a byte, it's just going to be a number. If I want to see it as a char, so that's byte 76. Then if I want to see that as a
yeah,
char,
that makes sense.
here, let me pass in 0 there. Let's just see what this. Bytes is equal to this. While numbytes is greater than 0, actually, I'm going to do it forwards first. So for and then we're going to print out all right, so this should print the file in order. We're going to first get the number of bytes. Then we're going to loop through and get each individual byte from this. So here's the number, here's the pointer. Open up the file for read only. Here's our buffer of 1. Do the same thing here. I is less than index, I plus plus. We're going to read from this guy into our buffer, buff size, ultimately returning buff at bucket 0, which should be the very last byte we read. Okay? So theory should be this should print out our file in order. Nailed it.
Print that out.
Got some of these Weird characters.
Well, that's what's in A.out.
Oh, this is the contents of A.out.
Yeah. Yeah, it actually did work.
Oh. We probably should pass it. Remember last time when we talked about the arguments and how argument 0 is the name of the file? The name of the calling program? That's A.out. That's where the L was coming from. Very nice. This will probably have a...
So it was working before, too.
correct.
Oh, cool.
Yeah, it's that L, the large uppercase L was correct all along because it's this elf thing. There we go. There we go. Mm-hmm. Whoa. And we're back. See, yeah, I typed reset and press enter because sometimes if you dump a whole bunch of binary data to the terminal, it gets a little bit off.
So what do we do?
Just type the word reset and press enter.
Let's type it in different language.
Yeah, but just do it and press enter.
Boom. Close one.
All right, that looks better. There we go. So that's our file in the right order. So now what we want to do is we want to walk our file from the end towards the beginning. So let's do that. So we'll say while num bytes is greater than 0, I think greater than or equal to 0, we're going to get num bytes, and then num bytes minus minus. So this should reverse our file, right? We'll grab the very last byte first, then the second to last byte, then the third to last byte, and so on and so forth. All right. And here, if you can see the very last line here. Pound include. Don't I want what?
I was just thinking if you were trying to get the negative 1 byte or not. But
Oh, this says all of them.
right, I know. I think that you were gonna go.
Because I know exactly how many bytes there are in there, because I counted them ahead of time.
Yeah.
So I know exactly how many times I'm allowed to do this. All right, so now we're reading it in reverse. Then we're printing it in reverse, but now we want to output it in reverse. So now we need to bring in our output stuff. So go back into copy. Is this copy? So we'll have int. Steal. I'll steal this for right now, then we'll take some stuff out of there. No longer need the input 50. Don't need this, don't need this, don't need that. There's our output file. Now we want to write to the output file. That's this guy right here. So I'm going to write whatever's returned by this. All right. constant void pointer, but argument is of type int. Oh, oh, this is right. This guy wants a void pointer. As the buffer. So I'm writing to this file. This guy's just returning. So I think what I actually want to do here is I want to return a char pointer from that, which will then just let me return buff. I'll write buff of buff size out. I think that should be okay. Copy, copy. Let's do it. Copy.copy. Ooh. Oh, I never closed the file. Close. Output FD. So each time through, we're going to output that buffer. That's the size. Subtract 1 from bytes. Well, same thing again. It's weird how it won't let you return char pointers without prototyping. All right, that's just the warning. All right, so that should be our file in reverse. Copy.copy. Oh, actually, I could just do this. So here's, oh, I have 2. Oh, I got 0 twice. Greater than 0. There's our copy. So, that's the file in reverse. All right, so
Wait, go back to that real quick. What was the last character? The first character?
first character,
Yeah.
copy. Let's see, this guy is exit.
Success.
Right, so the first, shouldn't that be like a closing parentheses?
Exit success. So what's this guy supposed to be?
The ending bracket, I'm guessing.
Just feed that file back into it and see if it comes out right.
No, I think I.
Is it exit success?
Right.
That's true. We should be able to.
No, it should be all the way at the bottom, right? No, in reverse. Oh.
Copy.uncopy.
Copy.copy.
Copy.uncopy.
That's right, isn't it?
No.
No, there's
You don't
supposed to
have
be
opposing-
brackets.
you don't have-
Oh no, I know what the problem is. We can't do a. It's one indexed. When we read a char, we have to read byte number 1. That's the problem. So if I come into this, we're gonna go as greater than 0. So I think I need to do num bytes minus minus burn 1, then keep going through as long as it's greater than 0. Just grabbing 1 off the end here. So grab 1, then 1 becomes 0. It should fall past it. Copy, copy. All right, so that's good there, but the very last thing we read is 1. No, this is the first thing it reads. Let's do it this way. Okay. So this is 1 to the number of bytes. No, that's good there. I think I have to say num bytes minus 1 here. Copy, copy. Well, that's even. That's what? Yeah. Because my loop is going on num bytes. I can't do that. I can't subtract num bytes and then go on num bytes here. So I can start I off at num bytes minus 1, keep going as long as I is greater than 0. I minus minus. There really isn't a difference here. This is basically the same thing we just had. So copy, copy. I don't know why it's getting that one extra guy.
Wasn't that supposed to be a bracket? If you go to your copy.c,
Is that just how it reads in brackets?
does it have brackets anywhere else? Has all that selected.
Yeah.
Go to the other thing. Can you put like the letter Q after it? Just like put something after the
Right.
bracket and see if it'll.
Well, it shouldn't break it.
Because it's just reading.
That's what I figured.
Copy.
Yeah, it just sometimes randomly says that you have things selected. Other people. Probably.
Yeah, it didn't even get the queue.
Did you close it? Reopen it?
Close what?
Copy.
Copy.
Oh, well, I saved it.
Copy.
Copy that. Copy. It should change, and then you have the old one open still. Say read double click. Copy that.
Oh, I understand.
That is different, isn't it?
No.
It's one line up. All right. Well, we'll figure it out on Wednesday. We're just reading one extra byte or one too few bytes or something like that. All right, I'll give you another assignment on Wednesday. We're going to look at what other things we might want to do with I/O stuff like this.